Hello students, welcome to you all. This is the third session for the chapter called Selection Statements. In our previous sessions, we discussed about the first module of selection statement, that is called else if statement, and the second module, that is else if ladder. Now in this session, we are going to revise what is else if ladder, and using else if ladder we are going to prepare some more programs. Let me revise what is else if ladder, which we already discussed in second session. So the else if ladder syntax, when we observe here the syntax of else if ladder, there's the syntax. So what is else if ladder? Defining n number of if conditions along with n number of associated statements. Here you can see this is condition 1, condition 2, condition 3, like this n number of conditions we can generate. Now for each condition we are going to define it's a corresponding block of statements. Now for this condition 1, this is the corresponding block of statement, and this is for the condition 2, this is the corresponding block of statements. So like this, for n number of conditions we define n number of block of statements. Now what is the execution criteria in else if statement? If we look into that, very first a compiler comes and it checks the keyword called as if. Along with it, it checks condition. Generally condition provides two types of outputs, called as boolean type of outputs, 1 or 0, which are also called true or false. Suppose the condition 1 is a true. You see the channel, when condition 1 is a true, it comes and it executes this corresponding block of this condition 1, and the remaining all statements will be bypassed or abstracted. Suppose the condition 1 is a true, then you see this channel, in this channel it will come out and it abstract this condition 1 block of statements, and it start to check condition 2 along with the keyword else and if. Now if this condition is a true, then its a corresponding block of statements will be executed, then rest of all statements will be abstracted. Suppose all these conditions are false, there is no condition is a true. During that time, the compiler executes the last block, that is called as else block of statements will be executed. So when condition is a true, its corresponding block will execute and rest of all statements will be abstracted. This is the criteria which is implemented in else if ladder. So using this else if ladder criteria, we are going to prepare some more programs. You can see, and let me open the text editor or IDE, that is BlueJ for Java. Yes, so in this we are going to prepare some programs. We'll create a new class, and a new class name, anything we will give, say it is else. This is the third program for else if ladder. I give else 3. Now in this class, what shall we prepare? So any program we will choose from the list. And what is the list? Let me show the list. The list of programs, when we observe, yeah, here the list of the program. Now in this, the first program, when we observe, the program is the standard form of a quadratic equation is given by ax square plus bx plus c is equal to 0. Generally, any quadratic equation which is in the form of ax square plus bx plus c is equal to 0, such kind of equation is called as advected quadratic equation. When degree 2 variable and degree 1 variable together when participate in one quadratic equation, such equation is called as advected quadratic equation. But in any equation, only degree 2 variable and other constant is associated, then that equation is called as a pure quadratic equation. The standard form of pure quadratic equation is ax square plus b is equal to c. That means only x square is the variable is going to participate, there is no x variable. Okay, come back. Now this is the equation they give, quadratic equation, that is ax square plus bx plus c is equal to 0. For this equation, to find out its roots or solutions, the solutions nature, it depends on a particular word that is called as a discriminant. So we need to calculate discriminant d is equal to b square minus 4ac. So b is the coefficient of x variable, and a is the coefficient of x square variable, and c is the constant. That's what we can see at last. So these all values we are going to substitute in the formula b square minus 4ac, that is called a discriminant. and if this discriminant is greater than 0, then the roots are real and unequal or distinct. Distinct meaning is unequal. This is what the first condition. Second condition is when we do this calculation, if the result becomes 0, then the roots are real and equal. When discriminant is less than 0, then we say the roots are imaginary. So this is the table. Finally, they are asking us to prepare a program to determine the nature of roots. So this is the nature of the roots for the quadratic equation by inputting A, B, C. Right, we'll prepare the program for this. So very first we need to input three variables. The three variables are A, B, C. Into that variables we need to assign some values. That values are coefficient of x square, coefficient of x, and a constant. So after inputting that three values, and they are going to assign into the variables A, B, C, and we need to calculate discriminant, that is b square minus 4ac. This is our second work. Now after calculation we will get d value, and that d value we are going to represent in LCF ladder. Using LCF ladder we are going to speak the nature of the roots. This is the nature of the roots. Right, let me open the IDE, that is BlueJ. In that we are opening LCF ladder. else3 is the class name, so we are writing class name is else3, and open the curly bracket. So else3 we are preparing. So in this curly bracket open, I am giving a new word, static. I'll explain what is the meaning of static. So what is the difference between non-static functions and static functions, I'll explain. In that we need to input three variables. So what are the three variables means I am using command line argument, that is A and B and C. So three variables we declared, and in that we need to take a variable discriminant d. Now we need to calculate d is equal to, formula is a b square. B square we can write in two formations. The two are, one is a math.pow of b comma 2, which represents b square, or we can write directly b into b. So I'm writing easiest way, that is b into b, because degree is less, minus 4ac. So 4 into a into c. This is the formula to calculate discriminant. Then once the discriminant it occurs, then we need to speak the nature of the roots by using the table. You can see this table. When d is greater than 0, we need to display the output here is roots are real and unequal. When is equal to 0, real and equal. When less than 0, the output is imaginary. This is what we need to display. Yeah. Then if condition is, first condition, d is greater than 0. When d is greater than 0, then we need to display the output, that is roots are real and equal. Unequal or distinct. This is the output we need to display. Then after this is the first case. Suppose the condition is d is equal to 0. When the this calculation represents 0, then we move to the next condition, that is else space if. So that is else space if the condition is d is equal to 0. So discriminant value is 0. Then what is the representation? So what is the representation we need to do here? So same criteria, same statement we are going to take, but instead of unequal we are going to take it as equal. So same statement I am writing. So output is, but instead of unequal the roots are equal. And last case, when discriminant is less than 0, generally any value when we observe, any constant when we observe, that value it is in three formations. First one is it may be positive, second one is it may be negative, and the third one is it may be equal to 0. Already we checked two conditions. One is it may be positive greater than 0, it may be equal to 0. Then finally, without checking, we can say it may be negative. For that sake, you need not to apply any condition, just you give else. In else block we will display the roots are imaginary. So we need to give the output as the roots are imaginary. This is the output. And finally, close the else block, close the main function, and close the class. Now in this case, how the compilation takes place, let me explain. So very first a compiler comes when we compile this program, then class will when there is no syntax error, then class is ready to execute. So let me compile. So it is asking system. Yeah, S must be capital uppercase letter. Why? Because system is the built-in class. Every built-in class should start with uppercase character. So that is capital S. Okay. Now click on compile. There is no syntax error. You can notice here. So when there is no syntax error, now class is ready to execute. But previous case, when we use non-static function, just we wrote void space main. During that time, the function can execute only after creating the object. So when you see, you can see in the next screen. So in the next screen, in this next screen, when you right click on this concerned class and when you choose new along with that class name, then object is going to be created. Then on the object, when you right click, you are going to see the function name called as void space main. That is represented in non-static form. Non-static form means without using the keyword static, the function is defined. So any function which has been defined without keyword called static, then such function is called as non-static functions. Here you can say yesterday we developed some program. So in this case there is no static keyword we applied, then this function is called as non-static function. So in non-static functions generally can execute after creating the object. Without creating the object, the function cannot be executed. Every non-static function belongs to one particular object only. But if we want to execute this main function, if we want to execute any user defined functions, then that function should define along with a keyword that is called as a static before starting off that particular function. That is what I did in this case. So in this program, we define the main function with a static keyword. So when we create a function with a static, then that function get the ability to execute either before creating of object or at the time of object creation. We can execute this function. You can see now, you can see in this case when I right click, you will see two options. The two options are new else 3. It allows to create the object. So when you choose this one, then object will be created. But what I told, without creating object also we can execute main function. You can see now second option, void space main. This was in previous case, there is no such option we notice before creating the object. You can see here area and cloth. This is what we developed in session 2. These two functions, these two classes, when we start to execute after creating the object only, we can notice this kind of statement void space main. But now we are noticing at beginning only. Reason is the function is defined with a keyword called as static. So what is the difference between static and non-static functions? A non-static function can execute after creating an object, and non-static function is belonging to only one particular object. Whereas a static function, the function which can be executed before creating of an object. At class level only we can execute the function. And the second one is the static function is common for all the objects. Whatever the operations which has takes place inside of the static function, and that operations are common for all the objects. This is the difference. These are the differences between static and non-static. Along with that, one more difference also you can state, non-static function is defined without keyword static, and static functions are defined with the keyword static. Right, now click on void main function. Without creating the object, it is asking us to input the coefficient of x square, that is a, coefficient of x, that is b, and a constant c. Let me give the value. Suppose I am giving 1, and b value I am giving -1, and c value I am giving say -12. Okay, so when I give this all values, then the equation, it becomes general standard form of equation is ax square plus bx plus c is equal to 0. When we assign these values, then that equation becomes 1x square minus 1x minus 12 is equal to 0. When we simplify, finally we will get -1 and -12. Factors are -4 and +3 you can write. So finally you will get x minus 4 in and x plus 3. So when we send it to right side, then x is equal to 4 and x is equal to minus 3. So two answers we are going to get, and they are not equal or distinct or unequal. So finally we need to get real and unequal. Yeah, you can see here. So output is real and unequal. This is the thing. Now to clear the output, Control K is the shortcut key to use. Right. Once again we will right click and click on this. Now I am giving some strange calculation, that is 1 I gave in A value, B I gave as something like 1, and the C value I gave 13. When it calculates b square minus 4ac, b square becomes 1, and 4 into 1 into 13, it becomes 52. So 1 minus 52, it becomes minus 51. So minus 51 is less than 0. Due to that we will get imaginary, roots are imaginary. Yeah, this is the output. Now you see how the compilation it takes place inside of the program. When I give 1 1 13, yeah, now I give A value as 1, B value as 1, and C value as 13. Now compiler comes and it substitutes the value in this corresponding places. So B value is 1, so 1 into 1 it becomes 1, minus 4 into 1 into 13. So 4 ones are 4, 4 into 13 52. So minus 52, and this is plus 1. So 1 minus 52, it becomes minus 51. D value became minus 51. Now that D value, it comes and it substitutes in the first condition. Compiler checks this condition along with the keyword if. Now minus 51 greater than 0, it is absolutely false. Once it is false, then it's a corresponding block of statements do not execute. Then compiler comes and it checks the next case, that is called as else if d is equal to 0. Now d place, when it substitutes minus 51, minus 51 is equal to 0. This is absolutely false. When it is false, then compiler do not execute this block, then it executes the last block, that is called as else block. Due to that we got roots are imaginary. This is the output we noticed in the last case. This is the program we wrote for the question called, for the question, yeah, this is the question. For the first question we wrote that program. Now you can see the second program. The second program is write a program to compute the amount that a customer to pay for the taxi that he or she hires based on the following conditions. Yeah, generally we take a taxi or cab through by some apps, or manually we call that taxis. So when we book through by online, through by some app, then the calculation of the taxi fare, which is like this is the format, but generally they used to do calculation in this format only. First 10 kilometers they charge 25 rupees per kilometer, this is rupees 25, and next 40 kilometers rupees 22, next 50 kilometers rupees 19, above 100 it charges 15 rupees per kilometer. So these are the different slabs, and we need to input customer name and cab number also, and number of kilometers traveled. And using this, finally we need to calculate how much fare has to pay by he or she. This is what the question. But inputting, you can observe customer name, it must be in composite data type, that is a string. Cab number also generally we say in Karnataka the number, vehicle number, it starts with the KA04 MGMI something, and along with that 4-digit number it follows. And next, number of kilometers are traveled. This is what also we need to input. Using these three values we need to calculate fare in different slabs. Okay, now we go back and open the IDE, that is a BlueJ, and create a new class. Class name I'm giving fare. This is the class name, and open the class. Right, now class name is a fare, class fare, and open the class, and I am giving static function again, static space void space main. Now in this class, before to create this class, I already told command and argument we need to apply, that is a string space name of customer we need to input, and we need to input number of kilometers and one more also, yeah, cab number it is in string form, so string space CNO cab number, and number of kilometers display in integer, so it is a KM. So after inputting a name of the customer and cab number and number of kilometers, now we start to calculate the fare to pay. Generally fare, it comes in decimal form also, so that's why I'm giving double data type variable, double space, I'm giving f is equal to initial value of double is 0.0 or 0.0t. Now apply the first condition. What is the first condition? Means if number of kilometers less than or equal to 10. Why? Because they mention up to 10 kilometers. So up to 10 kilometers they told, they mention, you can see the table. Yeah, this is the table. First 10 kilometers they are charging 25 rupees per kilometer. So that we need to write. So calculation is f is equal to number of kilometers into cost. You can observe carefully, cost is 25, so we need to take 25, cost into 25, number of kilometers into 25. Suppose I traveled 5 kilometers, so 5 into 25 rupees 125 I should pay for the cab person. Now next case is, next condition we always represent by using else space if. That's what I'm typing, else space if. Now the condition is more than 10 and less than 20, sorry, less than 40. This is the condition they give. So condition is km is greater than 10 and km is less than or equal to 40. At this case, how to calculate fare? Fare is equal to, in previous cases and all, we just wrote that is 40 kilometers means 22 into km, generally we write, but here you can observe a word that is called next. What that word it speaks, what is this word it speaks means, first 10 kilometers, for example I traveled 30 kilometers. When I travel 30 kilometers, first 10 kilometers they are going to calculate with the 25, so 25 into 10 it becomes 250. Hold that value 250. I travel 30 kilometers, for first 10 kilometers amount became 250. Then remaining 20 kilometers, that is kilometers minus 10. So kilometers minus 10 means 20 we got. The 20 into 22, that is 440. 440 and plus 250. These two should be added. So two calculations are participating. So previous 10 kilometers into 25 and this one is a kilometers minus this 10. For that we need to multiply with 22. This is what I am writing. So cost is f is equal to, for first 10 kilometers we need to pay rupees 25 per kilometer, and remaining kilometers represent like this, kilometers minus 10. Why 10 I am writing? Because already for first 10 kilometers we calculated. That's why kilometers minus 10, for that they are charging 22 rupees. This is the calculation. Again, else space if, third condition is more than 40 and less than, you can see. So for next 50 kilometers means, you can see first 10, next 40, sorry I made a mistake, next 40 kilometers means after 40 kilometers means it becomes 50 kilometers. So condition what it becomes here, you know, it becomes 50. What is the meaning of next 40? After 10, for 10 we need to add 40 kilometers, so it becomes 50. After 10, next 40 means it becomes 50. The next case what they told, next 50 kilometers, which means after 50 next 50 kilometers means up to 100 kilometers. For that we need to write, for that we need to define the condition like this, kilometers are greater than 50 and kilometers less than or equal to 100. Next 50 kilometers, I repeat, first 10 kilometers means this is the calculation. Next 40 kilometers, meaning of next 40 kilometers is after 10 next 40 we need to take. That means for 10 we need to add 40, then only the next condition it can be prepared. So kilometers less than or equal to 50 means 10 plus 40 it becomes 50. But third case you see, for next 50 kilometers, after 50 next 50, then what it becomes, kilometers more than 50, and for 50 when you add 50 then it becomes 100. In this case, how to calculate? You go back to the question. First 10 kilometers, you just practically you just assume the value, the number of kilometers. For example, I traveled some 70 kilometers. When I travel 70 kilometers in one particular cab, first 10 kilometers they charge 25 per kilometer. So 25 into 10, here it becomes the cost is 250. Why? Because 25 into 10. For first 10 kilometers is over. Now you read this word. For next 40 kilometers, 22. So 22 into 40 we need to calculate. So 22 4s are 880 it becomes. So 880. So here 10 kilometers is over. This is for 10 kilometers and this is for next 40 kilometers. Next 40 kilometers. But actually I traveled 70 kilometers. Now you can see here 10 is over, 40 is over. Still remaining how many? 20 more. Why? Because 70 minus above these two, sum of above these two. So for that, how to calculate means we need to calculate 20 into 19 remaining calculation. So how the 20 I got? The 20 I got like this. That is totally 70 I travel. That 70 from 72 I need to subtract this 10 as well as 40. So minus 10 minus 40. When I do this and that one when I multiply with this concerned cost, that is 19 rupees per kilometer, then I will get in this bracket. In this bracket, I will get to 20. Why? Because minus 10 minus 40 it becomes minus 50. 70 minus 50 it becomes 20. So 20 into 90 it becomes 380. 380. Yeah, 380. This is the way to calculate for this next 50 kilometers. That is what I am going to do. So calculation is F is equal to, for first 10 kilometers means, so 10 into, I need to type 25 per kilometer plus, first 10 is over. Next 40 kilometers, 40 into, I need to type 22 per kilometer. So for first 10 calculation is over, next 40 is over. Then for remaining, how to say remaining? Remaining is total kilometers. To from that to I need to subtract 10 and I need to subtract 40. For this I need to multiply with rupees 19. Then only the actual cost I will get if I travel in between the travel number of kilometers in between 50 to 40, 50 to 100. Now the last case, you see the table. Last case is above 100. Yeah, you can see here above 100. Above 100 means the cost is rupees 15. So for that next case, you need not to give any condition. Straight away we can give else block. In else block. Now how to give fair? Now even here also the way of calculation. Again go back and say this table. Feel that you traveled more than 100 kilometers. For example 130. When you travel 130, for first 10 kilometers, 10 into 25, it became 250. Then for next 40 kilometers, 40 into 22, it became 880. Then next 100 kilometers, so 100 into 19. So here the calculation, it becomes 100 into 19. Sorry, 50 into 19. Why? Because 50 is the case. So here 50 kilometers when you travel. So 50 into 19 when you give, it becomes 950. So 950. Then you can observe first 10 you got, next 40 kilometers you got, next 50 kilometers you got. So altogether 100 kilometers it became. But I travel for 130 kilometers. So how the remaining number of kilometers to calculate means from total means the total is 130. Just an example I am telling 130. From this 132 you need to subtract 10, you need to subtract 40 and you need to subtract 50. So then only the remaining kilometers you will get. That remaining kilometers you should multiply with this 15. Then only you will get the remaining amount. Then add all, that is the total fare to pay. Then same calculation, how can we represent? Fare is equal to first 10 kilometers you has to pay 25 rupees plus next 40 kilometers you has to pay 22 rupees plus next 50 kilometers you has to pay rupees 19 and the remaining kilometers, remaining how to say means total kilometers is stored in the variable km. From that to you subtract 10, from that to you subtract 40, from that to you subtract 50. Then the remaining kilometers it comes. Then that remaining kilometers you should multiply with rupees 15. Then only the total fare we get. Then finally we need to display previous case in previous program we use. So we need to display name of the customer. So I am giving that is a name of customer. name of customer is equal to, that is stored in the variable called name. This is what the variable. And next case, so we gave name of the customer. The next case, when you take the next, we need to display cab number also. So that's why system.out.println. So I need to give cab number is equal to, that is stored in CNO. Okay, right. Then next we need to display number of kilometers traveled, number of kms traveled is equal to, that is stored in the variable called km, we displayed. And finally we need to display amount to pay. So amount to pay is equal to, that is stored after the calculation. We will get the answer in the variable called as f. So represent f and close the bracket and close main function and close the class. Now compile the class. There is no syntax error. I already told shortcut to compile is Control plus K. To clear the screen also Control plus K. No enter. Then you see the output. Right click and execute directly main function, because of it is static. And every string data should enclosed in double quotations, and double quotations I gave A, B, C, D. This is a person name, any name we give. And next we need to input cab number in double quotations, KA something, AA some 1 2 3 4, some strange number I gave. And next we need to input number of kilometers. For example, I traveled some 70 kilometers. Then the bill is going to be ready. The bill is, we need to clear the previous screen. Right, once again we'll compile and execute the program. Right click and execute, and give once again double quotations, ABCD is the person name. And next we need to give KA something, AA 1 2 3 and double quotations close, and number of kilometers anything we can give. For example 150 I give, and click on OK. This is the output you can see. So person name is ABCD and cab number, it has occurred, it displayed, and finally number of kilometers and how much amount to pay. So with this, this is the output for the program. And try to understand for this how it is going to be executed. Very first we give a person name and cab number and number of kilometers, ABCD and cab number and number of kilometers 150 we give. Then compiler provides 8 bytes of memory for f. Into that the default value 0.08 stores. Now very first compiler substitutes the corresponding value of km, which we inputted before execution of the program. So 150 less than 10, it is false, so that this block do not execute. Again 150 greater than 10, it is true, but 150 less than 50, this is false. And operator, it states any one condition false also, the result is false. Next, due to that it won't execute this block. Then it moves to check the next condition, kilometers more than 50 true, but kilometers less than 100 it is false. So all three conditions are false. Then its corresponding blocks do not execute. Then compiler comes and execute the else block. This is the else block statement. Only one statement we defined for under each and every condition. When only one statement is defined, during that time you need not to give the curly brackets. You need not to provide open and closed curly brackets. By default, every condition can take one statement under it. If more than one statements, if you want to represent under one condition, then you should enclose that statements in curly braces. Right, come back. Now in this case, how the calculation it takes place. We inputted the value is 150. Due to that, first 10 kilometers it takes 25 rupees per kilometer. So 25 into 10, it became 250. Next case 22 into 40. Next 40 kilometers it takes 22 rupees. So 22 into 40, it becomes 880. Next 50 kilometers it takes 19 rupees per kilometer. So 19 into 50, it becomes 950. 950, 880, and here 250. Then next case, for the remaining kilometers more than 100, so remaining kilometers rupees 15. How it calculates means 150 in the place of km 150 it substitutes, then minus 10 minus 40 minus 50 altogether minus 100 it becomes. So 150 minus 100 it becomes 50. So 50 into 15, 15 into 50 it becomes 750. So 750 plus 950 it becomes 1700. 1700 plus here 250. 250 means 1950. 1950 plus 950. So 2830. This is what the output we noticed in the place of F. So whenever you notice the word called as next in the given table, during that time these type of slab calculations you should do. That's why I gave one question here. So take this third question as assignment, because the keyword, the word is the next is applied. So with the reference of the second program, you try to prepare answer for this program. So with this, I'm concluding this session, and in next session we will speak about third module of selection statements, that is called nested if statement. Thank you. Thank you.